Okay, so in this today we are going to discuss about time, speed, and distance. So this is a very basic concept, and we have to just understand the basic relation between time, speed, and distance, and we will apply those concepts in the problem. So first thing is that what is the relation between uh, time, speed, and distance. So we can write it that speed is equal to distance upon time, or a different way we can write it as distance is equal to speed multiplied by time, just multiplication. Or we can write in different way that time is equal to distance divided by speed. So we can write in three ways, but the same thing is the same, that this relation is uh, one relation, and we can write in the three ways. Okay, fine. Now, next point is, when we are solving the problem, we have to take care about unit. That unit means that in which dimension we are dealing with. So let's suppose our speed given in kilometer per hour. Okay, and we want to convert it meter per second. So we have to multiply by 5 by 18. So let us understand why we are multiplying by 5 by 18. So let us understand why we are multiplying by 5 by 18. So here, kilometer, 1 kilometer is equal to 1,000 meter. So we can write 1 kilometer is equal to 1,000 meter. Okay, and divided by hour. So one we know about that. Ki 1 hour have 3,600 second. Okay, so we two zeros are cancel out. Fine. So we will have 10 by 36, and we cancel by it by 2, so 5 by 18. So that's why when we are converting from kilometer per hour to meters per second, uh, we are multiplying. When we are converting kilometer per hour to meter per second, we are multiplying by 5 by 18. Similarly, if speed is given in meter per second and we have to convert it kilometer per hour, just reverse of it, we reverse of the 5 by 18, and we will convert it to into kilometer per hour. Okay, fine. Now let us understand one more important concept, which will be very useful for the problem, that is the average speed. So how the average speed is defined? So average speed is defined as total distance travel divided by total time taken. So before going uh, to the depth, first we have to clarify that what is different between average speed and the speed. So average speed is the speed which will be talking about the whole journey. Let me clarify you. Okay. So let's suppose a particle start or a car is moving in this direction. Okay. So the distance is x1. Fine. And then it goes in this direction. So the distance is x2. Then let's suppose it's going in this direction. Then distance is x3. Okay. Now we want to find out that what will be speed of the particle of the car at any point. So if we see in this motion and we are dealing with the constant motion, constant speed motion, constant speed motion means that we are going with same speed. The speed is not changing in particular distance. So in x1 we are going with constant speed. in x2 with we are going with constant speed also, but not may be equal to the speed of x1, but it may not be equal to the speed of x1. The thing is that here, let me use laser. Okay, so here so speed is uh, constant. Here also speed is constant. Here also speed is constant because we are dealing with constant speed. This relation is defined only for the constant speed motion. But when the car is going x1, its speed may be somewhat v1, but that is a constant speed. And when it is going from when it is traveling the distance x2, its speed, let's suppose v2, but that is also constant. And when it is traveling distance x3, so it speed, let's suppose v3, that is also a constant speed, but they are not equal. That x1 speed, x2 speed, traveling speed, and x3 traveling speed are not equal. So that is basic thing we have to understand now. So what is the average speed? So average speed is total distance traveled divided by total time taken. So let us understand this by example. So let's take previous example. So first particle go with speed x1, sorry, with distance travel x1 with speed v1. Okay, then it uh, goes x2 distance here with speed v2. Okay, then it travel x3 distance with speed v3. Fine. Now we want to find average speed. So average speed is total distance travel. So during this total motion, the total distance travel is total distance is equal to x1 plus x2 plus x3. Fine. Now we need to find out the total time taken. So let me clear the page. And so total time taken will be t1 is equal to, we know that time is equal to distance upon speed. So in first case, our distance is x1. So x1 divided by v1. Okay. Now in second situation, our speed distance was x2. So t2 is equal to x2 divided by v2. Fine. So in case, time is t3, and we have distance x3 divided by v3. Okay. So we have total time x1 v1 plus x2 v2 plus x3 vt, and we have total distance, that is x1 plus x2 plus x3. Now, so average speed is equal to, let me write here, x1 plus x2 plus x3, total distance travel, and total time taken is, first scenario, x1 by v1 plus x2 by v2. Third one is x3 by v3. Okay, so that's how we calculate the average speed. Now we go to the next point. So it is written that if certain distance is covered at x kilometer per hour and the same distance is covered at y kilometer per hour, then the average speed during the whole journey is equal to 2xy divided by xy and in unit of kilometer per hour. Okay. So we can rephrase this situation that a particle, a car is going, let me just use, okay. So a car is going from A to B, okay, with a speed x kilometer per hour and coming from B to A with a speed y kilometer per hour. Fine. So this point saying that uh, I mean, let's suppose a car is moving with the speed x kilometer per hour and the same distance is covering with the speed y kilometer, and the both scenario will be same. Fine. Now let us calculate average speed of the whole journey. So let's suppose that key the distance between these 2 points. Let me use separate pace. Okay. So a car is going from A to B, and distance between, let's suppose distance between these 2 points is z, and it is going with a speed x kilometer per hour from A to B and coming back same distance with y kilometer per hour. Fine. Now, so total distance will be total distance is equal to 2z. Fine. Total distance is equal to 2z. Now total time. Now we know about that time is equal to distance divided by speed. So from A to B, the distance is z and the speed is x. Plus, when it is coming from B to A, the distance will be same, but the speed is y kilometer per hour. So z divided by y. Now we have total distance and total time, so we can calculate average speed. Average speed, that is equal to total distance is 2z and total time is z by x plus z by y. Z will be cancelled out. We will take LCM, and the LCM will be xy, and here it will be x, here will be y. So we will solve it. So we will get 2xy divided by x plus y. So it is kilometer per hour, obviously. So it is the average speed of the whole journey which we have calculated. Okay. Now we move to next point. Uh, it is said that if a person change his speed in the ratio of m divided by n, then the ratio of time taken becomes n divided by m. So let us understand this. Okay. So we have this formula: distance is equal to speed multiplied by time. Fine. And we know about that. Another one is uh, time is equal to distance upon speed. So when distance will be constant, so what will be? Time will be inversely proportional to speed. Fine. When distance is constant, time is inversely proportional to speed. Okay. So time when distance is constant, time is inversely proportional to one speed. Okay. So when we take ratio of, let's suppose ratio of T1 divided by T2 is m by n, since time is speed is inversely proportional to time and time is inversely same thing. So the ratio of v1 divided by v2 will be n by n. So basic thing. Okay. Now another point is, if two bodies travel with same speed, distance covered is directly proportional to the time direct variation. So this is a very basic thing, that if his speed is constant, so distance is directly proportional to time. So this is a very basic thing which we need not to I mean, uh, nothing have to discuss about this. Okay. And third, and the first one point is, if two bodies travel for the same period of time, distance covered is directly proportional to the speed. That's the obvious thing. And the second point is, two bodies travel the same distance, time inversely proportional to 1 by speed. We already discussed about this. Okay, fine. So, fine. So, this is all about the time and distance.